Ooh, we got a good one. We got a double-sided infinite limit here. So we would break this thing up into two. It doesn't matter where we break it up. All right, so I'm going to do negative infinity to u of x over x squared plus 1 dx plus 0 to infinity of the exact same thing, x over x squared plus 1. All right, so let's look at these limits in parts now, right? So look at these integrals in parts, right? So if I just take this left one first, right, we can think of this as, again, by now we've done a billion of these things, maybe a little bit less than a billion. We're going from L to 0. We're taking the limit as L approaches negative infinity of this thing. Again, we want to be a little bit careful with taking the actual integrals. Don't think this is like an inverse trig thing or something. This is going to be a u substitution. U is x squared plus 1. So du is 2x dx. So dx is du over 2x. Right? So that means that this x and that x are going to cancel. We're going to have a 1/2 out front. So we're going to get 1 over u du. So we're going to get 1/2 the limit as L approaches negative infinity of the natural log of u, which is just x squared plus 1, which is always positive. So I'm going to drop my absolute value signs, like a pro. So when I evaluate this thing, we're going to get 1/2 limit as L approaches negative infinity of the natural log of L squared plus 1 minus the natural log of 0 plus 1, so just 1. All right, so we have a little bit of an issue, right? Because as L approaches negative infinity, L squared is blowing up, right? So if L squared is blowing up, L squared plus 1 is going to be infinite. The natural log of an infinite number approaches infinity. So we got an infinity in our integral. So this thing's going to diverge. And because this thing diverges, we don't even need to worry about this other side, right? This thing here, who cares? It's going to diverge as well. The thing should be like symmetric, right? Is this thing symmetric to the x-axis? I mean, y-axis? Yeah, probably. Like if you did this part, just, added bonus content of this video, this is why you get the Blu-ray edition, you would take the limit as r approaches infinity, 0 to r. We're going to get the same exact antiderivative. The natural log of 1 over u du, there's a 1/2 up front. So we're going to get 1/2 the limits as r approaches infinity of the natural log of u, which is x squared plus 1. Evaluated from 0 to r. Yeah, same thing. Right, so 1/2 limits of the natural log of r squared plus 1, which is still going to blow up towards infinity, minus the natural log of 1. That's this thing also infinite. So this whole thing diverges because both pieces diverge.